Hey guys. This is the lesson we did Friday and Monday, March 1st. So if you were at senior skip day or something, you missed it. These were the notes we took. And we investigated how we would test a claim, right? So we continued this idea of testing a claim in this gender discrimination. And now your homework is to make sure you have all your notes here, right? And this is just kind of, we use this random number generator. So we put the word random number generator into Google, and we clicked right here, and that's how we kind of generated the numbers. Maybe we'll use this again, but that was how we generated these numbers here, and how we decided how many were female and how many were male. And then let's take these notes here. Okay. So the basic concept here with these activities kind of chunk into three main learning targets. First, we noticed that we start out with some type of a claim. We call that a hypothesis. Okay. Now, the plural of this word is hypotheses. So if you notice, we actually had two. The first one we call the null hypothesis. Also, it's also called H sub O. And again, those are used interchangeably. So this is pronounced either, and I do both, hypothesis, the null hypothesis. Or we use the term H, the letter H, sub, and then O, like O, like OH, H sub O, O. Okay. Now, H sub O starts out, and in the chapter we're going to be doing, with our P. That's the proportion, that's the truth. And that actually is whatever we call that your null value. So in our example today, that was 80%. Like, you were supposed to accept the fact that I said I was an 80% free throw shooter. So P, not P hat, but P was 80%. We also saw in the men and women example of engineers, you were supposed to accept the fact that the proportion that was, well, this one was a little bit different. Yeah, we'll talk about that. I don't want to go too much into that, but okay. And then the other one, because that's why this is plural, is your alternate hypothesis. So if you thought, you know what, Steph Curry's actually a 90% free throw shooter, you're probably not as good as Steph Curry, or close to that. So your alternate hypothesis is that my free throw shooting was something less than that. You could have also thought I was being a little humble, right? Maybe it's something greater than that. That could also come up in this, the type of fact scenarios we're going to get. And you might just be like, you know what, I just don't think it's equal to that. It might be something bigger than that or less than that, but it's just not equal to that. So those are usually those are our choices when we do these types of problems. Okay, now all year we've kind of been doing this learning target 2. So what is that? That is when we interpret the p-value. All right, so we practiced that a little bit today. And we've actually been practicing it a little all year as well. Again, it's just kind of common sense. So we always want to assume H sub O is true. That's how we start out the question. Just like a court of law, we assume that you're innocent. But we might have a sneaky suspicion you're not. So that's where we get into a statistical analysis. So assuming H sub O is true, we say there is a blank probability of getting the observed result or more extreme purely by chance. So we uncovered that with the gender right? That in my 6th period class, we ended up getting half of the ladies did get selected by the lottery, or even more than half of the ladies got selected, even though this was generating only 1 through 6 as female and 61 through 180 as male. So it actually was a fairly, it's not incredibly likely, but we found that it does happen 21% of the time. That would be what you should expect to occur. So what do we call our probability? That's actually our p-value. So in that problem, excuse me, my p-value is 0.21. All right, okay, now my last learning target 3. So let's zoom in, learning target 3. Now, of course, we have multiple steps to these, and that's going to be my conclusion. So we usually start this by saying, because our p-value, whatever that is either less than or greater than alpha, which we presume, unless they tell us otherwise, that's 0.05. That's our threshold for rarity. Then we say we either do, or we might have to say we do not have convincing evidence for H sub A. Remembering you have to include the context. So if it's about a basketball hoop, you have to say the word basketball in your answer or in your conclusion, or you're not going to get your points, right? So my 2 scenarios is either my p-value is going to be less than alpha, so that means I do have convincing evidence. That will allow me to reject H sub O. And that's what happened today. You were able to go, oh, Ms. Grusmark's exaggerating, because the likelihood of getting that low of a proportion was actually less than 5%. So it's actually more likely that you were exaggerating, right? You reject the null hypothesis. Notice I'm not saying I accept my H sub A or anything. I can reject, you're not an 80% free throw shooter. That's too low a value to happen purely by chance. Now, what if I ended up getting a p-value, which ended up happening with the gender dispute, right? Then we ended up saying, we wanted to say that there was discrimination, but we didn't have sufficient evidence. So we failed to reject. We wanted to, but we failed to reject H sub O. Okay. Now, hopefully you take a minute to kind of pause the video, try to work through these questions, and then check your answers. All right, so welcome back. Hopefully you did that. I'm going to assume you did, and I'm going to read the question. It says, Fascinate.com claims that 84% of teenagers think highly of their mother. So that's going to be our H sub O. That's what we should accept as the truth, right? So P is equal to 0.84. And let's see, what is your sneaky suspicion? So it says, to investigate this claim, a school psychologist selects a random sample of 150 teens and finds that 135 think highly of their mothers. Does this provide convincing evidence that the true proportion of teens who think highly of their mother is greater than 0.04? So we have a sneaky suspicion that people like their mom even more than that. Maybe that's a little too low. Okay, so let's say that is our sneaky suspicion. Notice we have a p-hat. They did take a sample of 150. So our p-hat is our sample of 150. 130 said, yes, I think very highly of my mom. This is actually 90%. So see how we have some amount of evidence that it's greater. So that's kind of the reason for our sneaky suspicion. What is P? Well, we have to define this with context, right? We can't get full credit unless we add in context. And notice I've written nothing on my paper about teenagers and mothers, right? So P is the true proportion of all teens who think highly of their mother. Now, we can't ask them all. If we could, we'd know that. We wouldn't have to take a sample and make an inference, but that would be very costly and time-consuming. So we'd like to actually get this information, what is P, merely by taking a sample of P hat. Okay, so the school psychologist actually, so bingo, bango, bongo, they put it in the calculator. You haven't learned how to do that, but they did that and they got a p-value of 0.2. Is that rare? Well, I would say yes. So I'm actually going to do the one on the bottom first because I find this is logically, when I get this p-value, we know that because our p-value of 0.0225, because that is less than 0.05, then using our notes, right? Using our notes, we do have convincing evidence that the true proportion of teens who think highly of their moms is greater than, so we're not saying it is 90, just because our sample said that, that doesn't mean that's what it is. That was just one sample. So we are going to reject the null hypothesis. Reject H sub O. So you're like, well, wait a minute. What did this p-value mean? What does it mean when I say that p-value is that? Again, we look at our learning target 2, and we stick to our script. We say, well, assuming H sub O is true, assuming that 80% of teens think highly of their mother, then this analysis made by the calculator is telling us that there is a 0.0225 probability of getting a sample proportion of 135 out of 150, which was, that or greater purely by chance. Okay, well, explain what it would mean for the null hypothesis to be true in this setting. So looking here, what is my null hypothesis? Well, my null hypothesis is the true proportion of all teens who think highly of their mom, right? That's this information we received right there, okay? That's essentially saying that 84% of all teens think highly of their mothers. And the sample portion of 0.90 happened purely by chance. This is exactly what happened multiple times today because we literally simulated it based on that. So happened purely by chance. Nice work, guys. See you next time.